build a simple top-down 2D car controller in Unity. This controller is suitable for arcade-style games. So let's get started. Alright, so in Unity I've set up a simple 2D project where I've added a simple road. From this we will
How the hell did he add the road?
create
What does that show? The hell is the road? Why didn't he show us how he did the road? Whatever, who cares about that?
our car object, and it will just be a regular game object that we will call car. And from the sprites we will create our car object, and it will just be a regular game object that we will call car. And from the sprites we will drag the car sprite and put it just.
So I have a sprite here.
And from the sprites we will drag the car sprite and put it just on the car object, and we will rename it to sprite, and we will put it on the center of the game object at 0, 0.
Let's just do that, that's easier. Okay.
We will also make sure that the car is on the 0 of the z-axis, and we will just move it to the road. We will be using
Can we make this car a little bit bigger? Nice. Much better. Okay. It's kind of blurry. I don't know how to remove the blur. There's a way to remove the blur. It's kind of still blurry. How do you remove that blur? How the hell do you remove that blur? Full rect, I think. And no filter, yep. Right. Oh, there it is. Do you see how different it is? Okay, this is perfect. Okay, alright, perfect. I just need to figure out how to make the roads. That's later though.
Unit is built in physics, so let's add a rigid body component. And we will keep most of it as it is. We will just change the angular drag to 0.1. And we will remove the gravity scale, because otherwise the car will just fall off the screen.
Yeah, we need to remove the gravity scale on this. So how the hell did he do that? He had to add the render rigid body too. And you just do 0.1. And then you go to 0. And everything else should be exactly the same. Alright, perfect.
And we will change the interpolation to interpolated. So it becomes a little bit more smooth when we move it. Alright, then we will need our car controller. So let's create a script for that. And let's edit it in Visual Studio.
If you could reimagine your pet story, what moment would you change?
There was this meow that was so dramatic. It's like he was in pain. She wasn't really...
Damn it, whatever. Let me see here, we'll just get rid of everything else. In the public class here. Okay, in public class, we'll open a public float. No. Public what? What are we doing here? Let's see.
In Visual Studio, we will start by
We call it car controller too.
adding a few variables, and we'll make them into public so we can change them from the editor. So we start with car settings. We will need an acceleration factor, how fast the car will accelerate when we hit the acceleration button, and a turn factor, how fast the car will...
Okay, so we added new flow intervals, which is acceleration factor, and what is this? Steering factor or turn factor. Let's stay close to him, but a little bit far, so we can actually show that we know what the hell we're doing. And we'll change the numbers a little bit. Alright, perfect. So we have these two new floats that we just added.
turn when we actually, well, try to change direction. And from this we will need a few local variables. The first one is the acceleration input and the steering input. And then we will also need a rotation angle, so we know how to rotate the car basically.
Okay, I don't want to change too much, so we kind of like stay. So acceleration input, and I guess you can close it, right? No, you actually, if you don't want to give it anything, you just give it a 0, I guess. And then, what do we say? We say turn, steering. So this is a totally new word. I don't know why we introduced this new word. Okay.
Also, one is the acceleration input and the steering input. And then we will also need a rotation angle, so we know how to rotate the car basically. Also, we will need access to the rigid body component in Unity, so we will add a reference to that. And I prefer to actually attach them myself through the awake function. So we will use the awake function basically to get the component of the rigid body instead of...
So he calls out the rigid body and he gives it the name car rigid body. And then he goes and calls and creates a new function for it. Okay. it says here car rigid body 2D is going to equal to getting the component car rigid body, which is the rigid body, right? Yep, exactly. So basically you're reassigning what it is so the actual computer knows what it's doing. Then you close that down. All right, any other factors he's gonna
Of
add?
assigning it through the inspector in Unity. All right. As we're using Unity's built-in physics, we need to use the fixed update rather than the update function. And in our fixed update function, we will add.
Why can't we use our void update function? Void fixed update. What are we gonna add in here?
Two new functions. One to apply engine force and another to apply steering.
Okay, one to apply angular force. So apply engine force. And then the other apply steering. And then he's gonna he knows the physics on this, I think. And he's gonna go reference it in a second, right? That's what he does. You reference it within the actual...
In the apply.
No, you have to create the whole... Interesting. He's creating a whole new function just for the applied engineering. Apply engine force. Why are we doing that? Why are we having an error here? What's the error here? Yeah, we're gonna declare it. We're gonna declare it. What is the apply steer? Oh, it's an
Engine
error.
force, we will start by creating a vector, which will be the force that will be applying to the car. And we will take the transform up, which is the 2D equivalent
So
of.
how the hell does he know? I guess there's an equation here where the engine force vector is going to equals to the movement on X, right? Or no, to upwards. Times the acceleration input that we added up top times the acceleration factor. So transform up, what is transform up?
Forward, we will use an acceleration input and multiply it with an acceleration factor. Now, we also need to apply this to the physics through the rigid body. So we will apply a force that will push the car in the forward direction.
Add force, the engine force factor. And the force mode 2.0 dot force. And force mode 2.0 dot force. Okay, cool.
In this function, we will change the rotation angle of the car
Void.
And Unity themselves often
Applying
recommend that
steering.
you don't mess with the angles directly, rather that you use different type of forces to manipulate them. But when it comes to steering, I find that having exact steering is something that I really enjoy
angle.
in car games, and it feels a little bit.
Alright. We're gonna actually do it opposite to him, so equals to steering input times turn factor. Cool.
Sluggish when you're using the forces, so we will change the angle directly, but we will actually use the move rotation, which is slightly better than just changing the rotation value directly. All right, then we will need to be able to have a way to actually set the input vectors so we can turn the car. So we will just add a simple set function for.
He said we just add a simple set function to him. Okay, let's look at the simple set function that he created. It's a public void set input vector. For why did we make it?
To actually set the input vectors so we can turn the car. So we will just add a simple set function for it, which sets the variables based on input vector. We will then add another script. We'll need to be able to have a way to actually set the input vectors so we can turn the car. So we will just add a simple set function for it, which sets.
Vector 2 input vector. And this function is gonna call out steering input, which equals to the input vector. No. Yeah, perfect. On for x. And then we're gonna do, I guess, acceleration input, yeah. Acceleration input equals input vector, but on the y side. Interesting.
It's the variables based on input vector.
So yeah, so based on the input vector, what's the input vector? We haven't actually called out the input vector yet.
We will then add another script to handle
I
the.
don't think we can actually play this game yet. Let's save this and then go to the next script.
Input of the player, basically. So in the car input handler, we will add a reference to a component, the top-down car controller, and we will use the awake function again to get that component. We actually don't need a start, so we can remove that. And in the update function, we will.
So you go. So after he called it out. He went ahead and continued wait a minute. Wait. He called it, then he went into void again. In awake car controller 2D equals to get component of car controller 2D. Okay, cool.
We'll collect the input from the user, and we will use Unity's built-in features for that. So we will just create a vector2 input, and then grab the axis horizontal and vertical and store them. And then we will use the set input.
Alright, let me write up this vector. So vector 2 input vector Hello. What up? You want to see what I'm doing?
Yeah, I guess. What are you doing? I know you're
Huh? Look at this.
I can't see anything. It's just like frozen. Hello?
Yeah, can you see it?
No.
Why not?
The screen is frozen.
Oh, damn.
Yeah. Do you have WhatsApp? That's better, or Messenger?
It's okay. I was just gonna show you. I mean, I'm like playing around. What are you doing?
Just finished eating.
Nice.
Yeah.
You wanna come over or what?
Yeah, I can see. Okay. What were you doing?
I'm kind of like I'm streaming programming this game.
Yeah, I saw that you were like since yesterday you were posting this program and stuff. It sounds very interesting.
Man, I need to make the Gundam card game. Nobody made it yet. So I need to learn how to make it, and I have a friend that knows how to help me with it, but I need to learn, like, I need to know what I'm doing so I can actually upload it on my website and I can actually, like, post it. So I'm trying to figure out how to play it, but it's hard.
Yeah, programming is really hard. You know who knows how to program?
Who?
My sister.
Really?
She's very good at that. Yeah, she's
Your
really
older
good.
one?
Yeah, the older one. Wow. You don't know them.
Yeah, I can see that. I can see. I know, not the other ones.
Anyway, okay, but that's good. Like maybe we can ask her if she knows things
See.
she'll teach you. Yeah, it'll be difficult, you know, with the language barrier. though.
No, it's okay. I'm learning. The problem is, you know me, baby. I get really frustrated really quickly, so that's why.
Yeah.
And then, but the problem is also I can't sleep. Like I have to get it working too. So I have two problems.
Pretty much. Poor baby.
Yeah. What are you doing tomorrow, baby?
You know what we're doing tomorrow? What do you mean more?
When are you coming?
So tomorrow, I'm working. But night, remember?
Yeah.
Remember I told you?
I'll come pick you up.
What we're gonna do?
Yeah, I'll come pick you up.
See, and then
Go get some wings.
it doesn't have to be wings. I'm gonna bring food with me. We have pasta. I don't know. If
And
that's
then we'll
gonna
come
be
over and finish up.
Huh?
And then we'll come back home and give gifts.
Yeah, like I have pasta with chicken, and I'll bring a piece of pie, cheesecake. It's just like a tiny piece, but I don't know if that's enough for you. Maybe we can pick up some.
Maybe it's never enough for me.
It's not gonna be enough.
It's never enough.
You're fat, so.
I know.
Okay, then we go and pick up some more food, and then we go to the house, and we have dinner in the floor.
See, baby, I'll see you soon. Don't worry.
No, but you have to be nice. Like, I'm not messing around. I'm gonna be dressed up. If you're not dressed up, I'm not going with you.
Okay.
Okay? Like, very nice.
Where are we gonna go? We're gonna go to the party first or no?
We're not gonna go anywhere. We're gonna go home.
Oh, you just wanted to be.
Feel for each other.
Alright, I got you.
That's some good stuff. That's a
I
good
know
stuff.
we should do it. You're right.
Okay. So get ready. I don't know. I'll figure by 7 or 8.
7 probably sounds good. 7 or 8, yeah.
What sounds good, baby?
Okay, let's make it 8.
Sounds good. Sounds good.
I'll come get you. Alright, see you.
If I don't like you, I'm not.
I'll turn back around and go home.
Yeah, so you have to be handsome. Alright, honey. Happy
Te amo.
I love you. Me too. Bye.
See you, bye. Alright, guys, let's figure this out. Okay, so the input vector equals to vector 2. What is the dot 0? And then input vector dot x equals to the input dot get axis on the horizontal then we'll do the repeat the same thing. Equals to the input. What is input dot get axis? I actually don't know what this is. Never seen this function. On vertical. Okay. And we'll make car controller 2D. Set. Yep. Set input vector by the input vector that we set earlier. Yep. Perfect. Okay. So it's literally reverse engineered.
Function of the top-down car controller to update the input vectors. All right, great. In Unity, we will assign the scripts to the car object.
Alright, let's go ahead and do this. So the actual car object here.
And we will basically just drag them into the game object, and now we should be able to play the game.
Okay, let's try to play the game. I can't actually play the game. Why can't I play the game? There's no rigid 2D body attached to the car. Okay. Oh, I get it. I need to make a rigid 2D body. There we are. Okay, perfect. So how the hell did I forget to do that? Or was the game active? Or for some reason it was added into the image only. Maybe you give it to both. Let's try that. Let's try again. Okay, I'm not sure what that is. Let's remove this. And let's try this again. Oh my god. Let's go. Okay, try. Let's lower the speed a little bit because I'm like flying. Oh my god, this is amazing. My car's actually turning. How the hell did he get the physics of it to... It literally is a rigid body. I need to learn the rigid body physics. That's amazing. Like, I just have to draw some roads now. For some reason going backwards doesn't exist. Oh yeah, it does exist. Oh, but, oh, my physics is like screwed up. Okay, the physics are screwed up. So he's gonna fix it, I think.
So as you see, the controls are very floaty and the car is, well, like floating in space basically. So this pretty much our turns.
What does your video sound like? Go to artlist.io and get the best music and sound effects for your video.
So we will basically disregard all of these forces and focus on two. The side velocity, the orthogonal velocity, and the forward velocity. When the car turns, the side velocity increases, which causes it to drift. And right now it drifts far too much, which we see when we play the game, and it feels more like a space game. So what we will do to eliminate this in a very simple way is we will kill part of the side velocity, which will cause the car to drift less. If we kill it completely, it means the cars will go on rails basically and not drift at all. So let's code that. Let's open Visual Studio again, and we will start by adding a new variable that
What variable is it? Drift factor. And this drift factor, I'm assuming we're gonna figure out from...
is called drift factor, which controls how much the car should be drifting. Then we will add a new function called kill orthogonal velocity.
Where did he add it? Alright, kill orthogonal velocity. So you would do void kill orthogonal velocity, and then you would open this. Yep. And then you would send this down, and then you would write up the code, right?
Basically what it will do is it will remove part of the side forces as we turn the car basically. And the first part is that we need to calculate how much forward velocity the car has.
So vector
and the forward velocity, we calculate that by taking the transform up and multiply it with the vector 2 of a dot product with the car's velocity and up. That basically gives us a value how much forward velocity a car has. Then we need to calculate how much is the car going in sideways, and we do that by calculating the right velocity. And we take the transforms right, multiply it by the vector 2 of the right component instead. Alright, so now we have the two vectors, basically the forward velocity and the right velocity. And what we will do is that we will change the velocity of the car, and we will remove part of the right velocity based on the drift factor. So if we have a drift factor of 0, it means that it will not drift at all. It will basically run on rails. If we have a high drift factor of 1.0, then we will have the same spacey float as we saw before when we played the game. Now with a 0.95 we will have some drift, and it will be rather arcadey. So let's try that.
dot car
Awesome. See,
rigid
that
body
feels
2D
better already. And
dot
we're not quite done yet though. So we do have some rather strange things. It feels drifty and it's nice. But we can do this, which cars usually can't do. So we need to fix that with the steering. So let's go back into Visual.
Wait, what is he doing? So after he created these, he added it to the car rigid to body dot linear velocity, which is equals to the forward velocity times plus right velocity. Nice, yeah, he's right. It's plus right velocity times the acceleration. No, the drift factor. Okay, that's why we needed to create the drift factor. Cool. He's right.
Studio and look at the top-down car controller script. The apply steering function is what is causing this problem because the user is allowed to turn without moving forward. So we will add a minimum factor of the speed before allowing to turn. So what we do is take the car's velocity and divide it by 8. That's a value that I picked because it feels good. You can change that value if you want to. What we do then is we clamp this down into between 0 and 1, so we get a factor from it. And then when we are rotating the angle, we are multiplying it by this factor. So that means if the car is moving at velocity 0, this whole equation will become 0, so it won't rotate. Let's see how that works in Unity.
Wait.
Turn. So what we do is take the car's velocity and divide it by 8.
Flow minimum speed before allowing to turn factor magnitude divided by 8? What the hell? Where did he get this equation from?
That's a value that I picked because it feels good. You can change that value if you want to. What we do then is we clamp this down into between 0 and 1, so we get a factor from it. And then when we are rotating the angle, we are multiplying it by this factor. So that means if the
minimum speed. What is this equation? Where did he get this equation from? Math f dot clamp 01 min speed before allowing to turn factor. So what is this clamp function? I've never even used the math.f clamp function.
car is moving at velocity 0, this whole equation will become 0, so it won't rotate. Let's see how that works in Unity.
Alright, let's see how this works. What just happened to the car? Maybe my dimensions are too much. I don't know, this car is moving weirdly. I don't like his actual...
So this is looking...
Wait a minute. Maybe actually my... Let me play around with this. I guess it's actually accelerating, like it's not actually. Let's try that. I don't even know. Wait a minute. Maybe a little bit more turning factor. Let's see. What is that? Does this game do that?
Way better. But then we have some weird things, some additional weird things that we need to fix, like that the car is actually not slowing down when I let go of the accelerator button, and it never actually stops. So let's fix that. So let's go back into Visual Studio and open the top-down car controller again. We want the car to stop when the user lets go of the acceleration button. So we will add a drag, and that will basically slow down the car when there is no input. So we have 0 acceleration input. Then we will increase the drag to 3 over time. And if the user hits the accelerating button again, either in the positive or negative value, then we will remove the drag. This causes the car to stop slowly when you let go of the button, basically. So let's try that in Unity.
How the hell dot drag equals the math f dot lerp of the car rigid body dot drag with a frame of 3.0 f with time dot delta time function else car rigid body 2D dot drag equals to 0. Okay, cool. What is the dot drag though?
Nessa Tires, one of the 10 best tire stores in the state of Kansas. At Nessa Tires, you will find high quality new and used tires.
Damn it, what's the car 2D drag?
Again,
What the hell did we just do? Yes, delete all of this. So car dot drag let's do linear dampening equals math f dot lerp of the car dot linear damping with 3.0 frames at time dot delta time else rigid 2D body, the linear dampening will equals to 0. Yeah, I get why they had to change it to linear damping instead of drag.
Either in the positive or negative value, then we will remove the drag. This causes the car to stop slowly when you let go of the button, basically. So let's try that in Unity.
Let's try that. Yeah, but it's kind of weird. It's like the buttons are not doing it.
Okay, so now when I let go of the input, it slows the car down. And I can also do some pretty cool things, like if I start to turn and drift, like so, and let go of it, it will also slow down. So it makes it possible for me to make even more tight turn by letting go of the accelerator button. Sort of like in the real world, but much more arcadey. Another thing that is missing in our car controller is a maximum speed. Let's add that in the script. We'll start by adding a public float called max speed, and then we'll actually add another variable called velocity versus up, which we will use later on, and it's handy to have that one. So let's go to the apply engine force. In this function, we will calculate how much forward.
I'm such a genius. I'm actually gonna become I'm actually gonna take over all programming. What the hell happened to my car? Why the second it comes out of the screen, it's hard to come back? Is that the drift? Wait, is that because this is... Wait, let me look at this. Open sprite editor. Let me think about this. If I pivot this to the bottom center, would anything happen? Let me see. The game has changed a lot. Let me think. No, what you need to do is actually move it forward. Okay. So what you're gonna need to do is actually pivot forward, bottom, top, center. And actually somewhere like right there. I think this would be perfect. Actually, it's not changing anything. So it's not the pivot. Something is sending it like backwards when I click on it. It's weird. Anyways.
The car is going in. Another thing that is missing in our car controller is a maximum speed. Let's add that in the script. We'll start by adding a public float called max speed, and then
What is gonna be 0? No, 20.
And we'll actually add another variable called velocity versus up, which we will use later on, and it's handy to have that one. So let's go to the apply engine force. In this,
What is it gonna be?
we'll start by adding a public float called max speed, and then we'll actually add another variable called velocity versus up, which we will use later on, and it's handy to have that one. So let's go to the apply engine force. In this function, we will calculate how much forward the car is going in terms of its velocity. This is useful to limit the speed of the car, but also other things that we'll use. In the future. Let's start with a limit. So if the car is
This dot function is pretty useful, turns out. Transform dot up car rigid. Wait a minute. Car rigid body to
going
limit car to not go faster than max speed in the forward direction. So if velocity versus up is bigger than our max speed and acceleration input is not zero, is more than zero, then activate.
forward and its speed is bigger than the maximum speed and the user is pressing the acceleration button, then we will not apply any more force, so we will return from this function. Then we want to be able to do the same thing if the user is reversing, so we will limit it so it actually can just go half the speed when it's going backwards. And then we have another case where the car is basically going sideways when we are sliding or doing anything like that, or getting pushed by another object. Then it could be that we are actually accelerating and passing our maximum speed. So we add a test case for that as well, saying that if the square magnitude is larger than speed times speed and the user is pressing the accelerator button, then we will also return. Now with these changes, our car controller.
And then finally, if car rigid body with the linear velocity square magnitude is more than, this is a equation, like you need to go look it up, like you're not gonna know. Within the max speed times the max speed. And acceleration input. Excuse me, bigger than zero. Then also get out.
Is pretty much complete, and we have a lightweight arcade style car controller that can be used in any type of project. In the description we've added the source to this game, much complete, and we have a lightweight arcade style car controller that can be used in any type of project. In the description we've added the source to this game, so you can try it out on your own and change the values to find something that suits you and your car project. Hopefully we'll see some pretty
This is amazing. You know what it is? I think I know what this is. Okay. I think I just have to change the there's no velocity. Whatever. So this is a cool project. We're done with it. Get out of here, man. We maybe will do one more. Maybe we'll do one more later. Something like it, or we'll like enhance it. But
let's learn how to code. Sufficient Learner empowers
cool arcade games coming out of this project. Next video will focus on polishing up this game a little bit by adding tire marks to the game, some smoke particle systems, and also some sound effects. Hit that subscribe button if you want to get a notification.
That's that easy? It's that easy to create the game engine? API for card game Unity. At least I'm a little bit more understanding of programming. Oh, honestly, if I do this program one more time, one third time, I think we just do it one last time, guys. I think we go through this program one last time. Where is the actual API discussion for the card games? All right, let's do. I mean, I'm definitely better at reading code now. So basically, let's do one more. Let's do it one last time. Okay, let's do it one last time. Let's do it one last time. We'll do the whole code all over again. We'll restart the whole code. I'm liking this. I'm liking it. I'm getting better. I'm getting better. I think if we do it one more time today, it'll be secured in our brains and we'll be good forever. So let's just start all over. It's kind of scary, but let's do this. Okay, so we'll go sprites. Stop. What are you doing? Add the sprite here. We don't need the rigid component on it. Well, I think, no, we don't need it, right? Alright, and then we'll move the sprite right here. Then we'll go into the car. Well, we'll go into the scripts. Really. Just need to make sure that we interpolate. I guess what's let's do none. Let's see what that does. I don't know what to tell you guys. Like when I click left and right, it's not good. So this last time, oh, to the right it's perfect, but to the left it's bad. Let's see if we can add that. Let's do a left velocity vector. See if that will help. Left velocity, which is equals to transform to the left. I don't even know if they have this. Let me see if I complete it. Does it actually assign it itself? To the car, rigid body 2D, the linear velocity, right? Linear. No, the left function doesn't actually, like, there's no transform left. How do I turn left? Let's try this. So now it doesn't even turn. I don't know why, but when I turn to the left, it doesn't turn very good. I don't know why. Oh damn, I didn't save it. What the hell is it then? Alright, let's check it now. As long as you're turning... Wait a minute, is this because of the pivot I did? see. You know what it is? I think I know what it is. It's the drifting factor. Oh, okay, then it's a turning factor. I think it's a turning factor. The physics of it is weird. The physics is weird. Physics is actually weird. Let's see if this fixes it. No, the physics is bad. I guess we do another project. We just go find another project.